Hello everyone, welcome back to Diksha Vedantu Foundation channel, and today is day 29 of 99% in 99 days, and today we are going to discuss the previous year questions from the chapter Human Eye and Colorful World, right? So without any delay, let's start with today's lecture. First, we will see how many questions we are going to discuss. So there will be 5 MCQ questions from this chapter. Then we will also discuss assertion and reason based question, that will be 3, and 9 to 15 there will be short answer type question, 2 mark questions, 7 questions. Again 16 to 19 short answer 3 marks question is 4. There are very few questions as a 5 mark question from this chapter, so only 1 question is there, and sometimes they ask case based questions from this chapter, so 2 total case based question. So without waiting, let's start with the MCQ first. The near point and the far point are determined with the regards to the function of which part of the eye? Okay, pupil, eyeball, retina, ciliary muscle. So the basic part is that the near point and far point are basically determined by ciliary muscles. So ciliary muscles is the right answer, right? Because by contracting and expanding ciliary muscles we can adjust our distance of vision, and based on that we can watch closer objects or distant objects. So ciliary muscles is the correct answer for this question. Next is, which of these is the reason why a far-sighted person needs a convex lens to correct his vision? So far-sighted person means he can see far objects but he cannot see nearby objects. So you have to understand, far-sighted means he can see far objects, near-sighted means he can see nearby objects. Okay, so far-sighted person means he can see far objects but he cannot see close objects. Now let's see what are the reasons given. The image forms in front of his retina, the image forms behind his retina, the image forms below the retina, the image forms on the retina. So basically, as you can see, option C and option D are not the option, right? If option C and option D are basically option D is the eye is perfect. If it image is forming on the retina, then it is perfect, and there is no way image can form below the retina. So image will either is forming in front of the retina or it is forming behind the retina. Now in case of far-sighted person, we can see the far objects clearly, but when the object is very close, the rays are going behind the retina. That's why he needs a convex lens so that the rays can converge earlier and it can form on the retina. So image is forming behind the retina. So you have to be careful. Convex lens is used to make it more converging. More converging means if it is going behind the retina, then only the convex lens can fix it and it can focus on the retina. Okay, next question is, a person's near point is at 45 centimeter and far point at 2 meter. What kind of corrective lens is best suited for his vision defect? So basically near point is 45 centimeter, which is quite far compared to the normal vision, which is 25 centimeter. So he is suffering from myopia. Also he is suffering from hypermetropia, and far point is 2 meter. Far point for a normal human eye is infinity, so he is suffering from myopia as well. So both conditions is prevalent. So basically it means he is suffering from presbyopia, mostly due to age. So what will be the correct answer? Correct answer will be bifocal. Bifocal is a lens which is used to correct the near vision as well as distant vision. So both vision can be corrected using bifocal lens. So correct answer for this question is bifocal. Okay, I have discussed that during our regular class, if you remember. Next question is, the least distance of distinct vision for a normal eye is? Least distance of distinct vision for a normal eye is 25 centimeter. Be careful, do not mark 25 meter by mistake. Okay, so 25 centimeter is the least distance, and normal maximum far point or maximum distance is basically infinity. Okay, be careful while answering such questions. Which of the following phenomena of light are involved in the formation of a rainbow? So in formation of rainbow, which of the following phenomena is responsible? Let us understand. Reflection, refraction and dispersion. So reflection and dispersion are involved, but what type of reflection, that is not mentioned. So let's go back to the option B. Refraction, dispersion and total internal reflection. So obviously this is the correct answer. The reflection is not ordinary reflection, it is a total internal reflection. If you remember, inside the water droplet, the white light enters, then it starts dispersing, then once it dispersed, it gets totally internally reflected, and then they come out so that we can see the beautiful rainbow, right? So this is the path of the light inside the water droplet, right? So it not only involves refraction, this stage is refraction, then this is dispersion, then this is total internal reflection. So all these three parts are involved. So correct answer is option B. Next, now let's look into assertion and reason based question. This is a very difficult questions to answer. Most students don't understand how to answer such questions. So let's see. The danger signals installed at the top of tall buildings are red in color. We know that the red signal in traffic signals or in any top of the building where it is given to some other objects, that there is a building in front. So those are all installed in red in color. Why they are installed in red in color? Red light can be easily seen from a distance, because among all other colors the red light scatters the least. Yes, the red light scatters the least. So correct assertion is obviously correct, and reason is actually the correct explanation for the assertion. So both assertion and reason are correct. Okay, so in your test I have just changed the option B and gave it scatter the most. So basically that was not correct, but in this case assertion is correct and reason is also correct for this given assertion. Okay, you have to identify if this reason given in the statement, first of all, if both of the statements are correct or not. If both statements are correct, then you have to determine, okay, whatever is given in the reason, if it is correctly explaining the phenomena given in assertion. Okay, if that is so, then both are correct and reason is correct explanation. But if they are individually, they are not dependent on each other, they are correct on their respective terms, then you can say both are correct but reason is not correct explanation. Okay, that's how you determine. Next, another question. The rainbow is a man-made spectrum of sunlight in the sky. So first of all, assertion, as you can see, rainbow is a man-made spectrum of sunlight in the sky. It is definitely not man-made, so assertion is incorrect. First of all, you have identified this statement is incorrect. Just check if the reason is correct statement or not. The rainbow is formed in the sky when the sun is shining and presence of water droplet at the same time. Yes, this is correct. Reason that sun is there and also the water droplet is present, then only you can see rainbow. So basically reason is correct statement, but assertion is not correct. So assertion is false but reason is true. Option D is the correct answer. So you have to identify in this case. Okay, next question. The near point of a hypermetropic eye is more than 25 centimeter away. Yes, for a hypermetropic eye the near point recedes further, so it is more than 25 centimeter. Hypermetropia is corrected using spectacles containing concave lens. So there is no direct relation, first of all. Secondly, obviously it is not a concave lens, it's a convex lens. So reason is false, assertion is true. So option C is correct answer in this case. So you have to be careful if the reason and statement both are correct. First check whether reason and assertion both are correct. If first check is passed, then you check whether the reason explains the assertion or not. Okay, so in this case assertion is correct, reason is false, so you don't need to worry too much about whether it is explaining or not, right? Now let's move on. And if you are also like someone who is confused about your future, what to do in future, what should you study, many of your parents and corresponding friends, they have some dreams that I want to become a doctor, I want to become an engineer, but you are not so sure, then you can attempt our DSAT today. Okay, what is DSAT? DSAT is Diksha Scholastic Aptitude Test. Here there will be a 1 hour lecture and a doubt clearing session. based on that lecture, whatever doubts you might have, that doubts will be cleared, and based on that 1 hour lecture there will be an aptitude test for you. Okay, once that aptitude test is done, then that aptitude test will test how much you can remember, how much you can apply based on that concepts. Okay, if you are ready for any of these main course for your future, for example, if you are ready for JEE, or if you can take up on a difficult challenge of cracking NEET exam in future, or if you can crack KCET exam to take admission in engineering colleges across Karnataka. So if you are ready for these or not. Okay, so and based on that result, one counselor will guide you for your future, what is best for you. Okay, this is a very comprehensive test. Okay, and this will test your readiness for any future difficulties, right? And if you are interested, go back to the comment below and fill this form. This is a very interesting thing that is going on in our Diksha campuses every Sunday. Okay, and just fill the forms, and our representative will contact you for any further details. Okay, now let's look into the objective type questions now. States the reasons for myopia. With the help of ray diagram, show the image formation by myopic eye and correction of myopia using an appropriate lens. So reasons for myopia is excessive curvature of the eye lens and elongation of the eyeball. So if the eyeball is elongated, rays are forming even before they are reaching the retina, and excessive curvature of the eye lens, that means your eye's focal length has decreased, it is more powerful now, that's why you need to reduce the power using a concave lens, right? So this is the reasons for myopic eye, and the diagram is given in your book very correctly. So this is the myopic eye, normal myopic eye. So they have given you, you have to draw the both diagrams. Okay, image formation by myopic eye and correction of myopia. Okay, myopic eye is this, and correction of myopia is using a concave lens, where the rays are forming even before they are reaching the retina, and rays are forming here, they are reaching the retina easily. Okay, next question is why Tyndall effect is shown by colloidal particles. State 4 instances of observing the Tyndall effect. So let's see why the colloidal particles are involved in Tyndall effect. Colloidal particles are large enough to scatter light in all directions. So colloidal particle means what? Like milk. Okay, colloidal particle means if you add some partially soluble substances into the water, for example glue. Okay, if you add such things in water, then they becomes colloidal. Okay, and when a beam of light passes through the medium, making the path of the light visible. So the path of the light gets visible, and the examples are sunlight in forest. So if you are visiting a forest, you will see some beautiful sunlight coming through the forest. I have shown one of the diagram during my lecture. Then beam of light in a dark room. So if the room is completely dark, there is a small hole, and light rays are coming through the small hole, the path of the light becomes visible. Okay, because the dusts are present inside the dark room, and thus dusts are scattering the light, that's why the path is visible. That is also a Tyndall effect. Headlight in a fog. So inside a fog, if you switch on the headlight of a car or a bike or any other light, it shows the path of that light, because this is also a Tyndall effect. Okay, milk in water. If you add a couple of spoon of milk into water, this becomes a colloidal solution, and this also makes the path of the ray visible, right? These are the 4 examples. You have to remember them. Okay, first 2 are easy to remember, next 2 you have to remember. Okay, now next question, differentiate between glass slab and a glass prism. What happens when a narrow beam of monochromatic light and white light passes through a glass slab and a glass prism? Let's see. So first of all, this portion is optional, the property is optional, but these two table you have to mention. What are the differences? First of all, in terms of shape, rectangular with parallel surfaces. Okay, so they have asked you differentiate between glass slab and rectangular prism, so you can obviously take up their geometric shape. Okay, a glass slab is like all the sides are parallel to each other. You can even draw one diagram if you wish to. Okay, so glass slab is like that, and glass prism is triangular with no parallel surfaces. So this is the glass prism. Okay, this is a glass prism. This is a three-dimensional thing. Okay, next is refraction. The emergent ray is parallel to the incident ray. Lateral displacement happens. We know that the emergent ray is deviated from its original direction. That is also true. Okay, dispersion does not disperse light significantly, disperse white light into its constituent colors. So glass slab basically can be considered as construction of two prisms. One is dispersing, another one is joining them. That's why glass slab do not show dispersion, but prism does show dispersion. Next is now what will happen if you pass monochromatic light. I have given you the detailed explanation. You can short that description based on your understanding. Okay, the light undergoes refraction but emerges parallel to the incident beam after displacement. So light after incidence after diffraction through the glass slab, okay, it emerges parallel to the incident beam, but there is a lateral displacement. So if the light was going from this direction, the light will come out parallel, but this is also there will be some lateral displacement, but they are parallel to each other. What else? No splitting or color change occurs. Okay, so the light does not change any color. That is also very, very important. Next, what? Through a glass prism, the light bends to the refraction and emerges deviated from the original direction. So it does not have any relationship with the initial direction. Okay, it bends and changes its direction, and there is a deviation. Not only lateral displacement, but there is a deviation angle also. In case of glass slab, the deviation is 0, obviously. No dispersion no dispersion happens as it is a single wavelength. Obviously monochromatic light, so dispersion will not happen in case of glass prism as well. Very, very careful. Monochromatic light means single color. So when you pass a single color through a glass prism, it does not show any dispersion because it cannot break a monochromatic light, right? Next is through a glass slab. Now we are passing white light. What will happen? The light undergoes refraction and emerges parallel to the incident beam as usual. First case is same. Okay, no dispersion occurs because the parallel surface cancel out any splitting of the colors. So second point is slightly elaborated. Now in case of glass prism, again the first point is same. Okay, the light is refracted, dispersed into the constituent colors. Okay, that is we are receiving the spectrum. Okay, the different wavelengths bend different amounts, creating the familiar rainbow effect. So familiar rainbow effects you can see if you are using white light into a prism. Okay, be careful, answer correctly, you will get full marks. Okay, the answer is slightly longer for a 2 marks question, but question is given as that, like that. So what to do? Next question is, with the help of a labeled ray diagram, show the path followed by a monochromatic light when it passes through a narrow beam of glass prism. What would happen if the beam is replaced by a narrow beam of white light? So basically this is the diagram for a narrow beam of light, for monochromatic light passing through a glass prism. You have to mark this is incident ray, angle of incidence. Okay, this is the refracted ray inside the prism, this is the emergent ray. Okay, everything you have to mention, all the angles you have to mention. Okay, incident ray, refracted ray, emergent ray, these three you have to mention. Diagram as much as possible you can do it correctly. And when you are using different colors, the colors of light bend through different angles with respect to the incident ray as they pass through the prism. The red light bends the least while the violet the most. Thus the white light splits into 7 constituent colors after passing through the prism. Now they have not explicitly mentioned draw the diagram, and I feel that using 7 colors is difficult to draw, so they have basically asked you to explanatory answer. Okay, so you have to explain what would happen if you are passing a white light through a prism. Okay, so basically same answer that you have written in the previous question, same answer, but only in this case you have to write it in statements. Right, next question. Define the term power of accommodation. Write the modification in the curvature of the eye lens which enables us to see the nearby objects clearly. Let's see the answer. Ability of the eye lens to adjust its focal length is called the power of accommodation. So we know that only the power of accommodation was asked, so you have to answer only the part of the power of accommodation. Next is only the nearby objects. How we can see the nearby objects? So when you are looking at objects objects closer to the eye, the ciliary muscles contract, making the eye lens thicker and the radius of curvature decreases. Okay, consequently the focal length of the eye lens decreases. This enables us to see the nearby objects clearly. So now object is close, we have to decrease the focal length so that we can see the nearby objects clearly, right? So that's how we see the nearby objects. For distant objects, our ciliary muscle relaxed so that curvature decreases and focal length increases. In that case we can see the distant object clearly. Okay, so this is the way of seeing the objects which are far. So in this question in Delhi set 1 2019, the question was based on how you can see the nearby objects. For distant objects, it is exactly opposite. Instead of ciliary muscle contracted, in that case ciliary muscle gets relaxed. You have to remember that as well. Now let's look into the next question. Write the structure of eye lens and state the role of ciliary muscles in the human eye. So the eye lens is composed of a fibrous jelly-like material. Its curvature can be modified to some extent by the ciliary muscles. This is Delhi set 2 questions. So similar questions came in that year as well. When the ciliary muscles are relaxed, the lens becomes thin and the focal length increases. This enables us to see distant objects clearly. When you are looking at objects closer to the eye, the ciliary muscles contract, making the eye lens thicker. Consequently, the focal length of the eye lens decreases. This enables us to see the nearby objects clearly. So this is how you can see distant and close objects clearly using the ciliary muscle. Okay, now let's look into the next question. What is a rainbow? Draw a label diagram to show the formation of a rainbow. So draw a label diagram. Here you have to label it: incident ray, sunlight. Okay, this is the raindrop, and this is the dispersion happening. Okay, this is the raindrop. Okay, and as you can see, this is the dispersion of light. If you are using colored pencils, you can use color, but if you are not using colored pencils, then you have to mark it. Here you have to mark violet, here you have to mark red, so that teacher knows which part is what. Okay, so as you know that red scatters the least, so that's why it is going straight top part, and violet scatters the most, that's why it is going down. And after the refraction, as you can see, after here it is total internal reflection, and as it emerges out, now red is on the top and violet is on the bottom. Okay, now next, define the term dispersion of white light. State the color which bends the most, the least while passing through a glass prism. Draw a diagram to show the dispersion of white light. So dispersion of white light diagram, I have already drawn it. Okay, but let's see the splitting of white light into its 7 component colors as it passes through a prism is called dispersion of white light. So they have asked you dispersion of white light. So when the light is passing through a prism, it splits into its constituent colors, constituent 7 colors. Okay, the violet bends the most, as I said, and the red light bends the least. Okay, and the diagram is given such as this. Okay, dispersion of white light, in this case you have to draw using sunlight or white light. Okay, and as it passing through the prism, you have to show the different colors. In case you are using you don't have a colored option, obviously I don't expect you to have all the 7 colors. You have to draw this rays, 7 rays, and mark them VIBGYOR in the order of VIBGYOR. Okay, so that they are clear. Okay, so violet, indigo, blue, green, yellow, orange, red. Okay, at least first letter is sufficient. If you can write all the names, that is very good. Next is a person is unable to see clearly. Now these are the 3 marks questions, right? So the questions will be slightly longer. A person is unable to see clearly a poster fixed on a distant wall. He however sees it clearly when standing at a distance about 2 meters from the wall. Draw a ray diagram to show the formation of image by his eye lens when he is far away from the wall. List 2 possible reasons for the defect of vision. Draw the diagram to show the correction of his defect using the appropriate lens. So first of all, he can clearly a poster fixed on a distant wall. That means he is suffering from hypermetropia. Okay, he can see distant object clearly, but he cannot see object which is the person is unable to see clearly a poster fixed on a distant wall. Okay, so distant wall, he cannot see distant object. That means he is suffering from myopia. Okay, he is however see it clearly when standing at a distance of about 2 meters from the wall. So you have already drawn the diagram for myopia. You have to use the same diagram for myopia here as well. Draw a diagram. So diagram part I am not doing it. List 2 possible reasons for this defect of vision, that also we have done. Why the myopia occurs, the eye lens elongated or the curvature of the lens increases. So both are possible. Okay, focal length of the eye lens decreases. Any one of the point you can mention. Draw the diagram to show that the correction is also we have done. This question is already done in our previous question, right? So that's why we are not going to discuss it, but we can check previous answer. Okay, the PDF will be available to you. A person is suffering from both myopia and hypermetropia. What kind of lenses can correct this defect? How are these lenses prepared? So first of all, what is the lens? First of all, you have to use bifocal lens. To correct this vision, you have to use bifocal lens. Now, how these lenses are prepared? These lenses are designed with 2 parts. The upper part is a concave lens to correct myopia, help focus distant objects. The lower part is a convex lens to correct the hypermetropia, help the focus the nearby objects clearly. So, as you can see, a lens having concave as well as convex. So, first of all, as you if you have seen that suppose this is the lens, eye lens, this is the spectacles. So, here you have a convex lens. Here you have a concave lens. So this is a concave and here you have a convex, right? This is how you are able to see the distant as well as close objects clearly. So what is the other part? A person needs lens for power plus 3D for correcting the near vision and minus 3D for correcting his distant vision. Calculate the focal length of the lenses required for correcting these defects. So let's solve this part very easy. P equals to 1 by F. Okay, when F is in meters, in case of reciprocal of if you find the reciprocal of power, you will get the focal length, right? Now this is this gives you the focal length in meters. Now if you want to convert it into centimeters, what you have to do? You have to multiply with 100, right? So for plus power 100 divided by 3, so that is plus 33.33 centimeter, and for negative focal length it is 100 divided by minus 3, that is minus 33.33 centimeter. Okay, so this is the answer, simple solution to that, right? But you have to mention the sign. Both of them have plus 3 and minus 3, so both the answers will be same, but you have to mention the plus and minus sign. So concave lens is negative, convex lens is positive. Okay. Next question, a student needs spectacles of power 0.5D for the correction of his vision. Name the defect of vision the student is suffering from. Plus 0.5D. Plus power means what type of lens we need? What lens has a positive power and positive focal length? Only convex lens has positive focal length and positive power. So convex lens means what type of defect it is? It is a hypermetropia. So it is hypermetropia, right? And find the nature and focal length of the corrective lens. What is the nature? Nature, obviously, because it's a plus power, it's a convex lens, and the focal length is 100 by P. It is 100 divided by 0.5, that is 200 centimeter, or you can write it as 2 meters. Okay, both are correct. So find the nature and the focal length. Focal length is 2 meter. List 2 causes for this defect. What are the causes for hypermetropia? The length, eye size of the eye is contracted. Okay, it is shrinked, or the eye muscles curvature of eye lens has decreased, so that the focal length increased. So that is the 2 possible reasons for this defect of vision. Okay, so causes: the focal length of the eye lens is too long. The focal length of the eye lens is too long. The eyeball has become too small. So these are the 2 causes. Let me solve the focal length quickly. So 1 by P, that is 1 by 0.5 that is 2 meters. In terms of meters, it is 2 meters, or you can write it in terms of centimeter as well. So here the value is okay, 0.5, which is less than 1, so you can divide it and you can find it in terms of meters as well. But don't worry, and it's a convex lens, right? Next is observe the following diagram and answer the question that following it. Okay, identify the defect of the vision shown. So what is the defect of the vision? So as you can see, distant rays which is coming for far off object, after reaching the eye lens, they are getting focused even before they are reaching the retina. So this is a myopia. Okay, myopia. And what are the causes? We have already discussed the causes: elongation of eye lens, or increasing the power of the eye, or increasing the curvature of the eye, that decreases the focal length. These two are the causes for this defect. Name the type of lens used to correct the defect. So what type of lens is used? Concave lens is used. Okay. The color of the clear sky from the earth appears blue, but from the space it appears black. Why? So color of the sky is blue because blue light scatters the most. Okay, but when you are in the space, there is no atmosphere for scattering of light to occur. So that's why though no scattering happens and all the lights are not present there, so you cannot see any color. You see black color when you are in the space. Okay, only because the scattering is happening and the blue light is getting scattered and reaching our eyes, we see blue sky. In outer space there is no scattering, so no blue sky. Clear? Okay, on earth the atmosphere is scattered, sunlight making the sky blue. In space no atmosphere means no scattering, so the sky appears black. Okay, so these are the last questions point. Next, now it's a case based question, so it's a long question. There will be a long statement. White light passes through one face of a prism. It's get deviated. This deviation is different for different wavelengths of light. Since different colors of light have different wavelength, the deviation of different color is also different. As a result, when light emerges from other face of the prism, we observe 7 constituent colors of the light. This phenomenon of splitting of white light into its constituent colors is called dispersion. Which light would be fastest in glass? So if you know which light is fastest, red light would be fastest in glass because it scatters the least. Violet light is the slowest in glass because it scatters the most. So whoever is fastest, they will pass with the smallest possible path, right? And as you know that red light travels the smallest path because it is the fastest light. Okay, next is what is the cause of dispersion? So cause of dispersion is different light travels in different speed. Okay, when light passes through medium like glass, each color or wavelength, you can say, the light bends by different amount due to this variation. Shorter wavelengths like violet are refracted more, longer wavelengths like red are refracted less. So different colors are getting diffracted by different amount. That gives rise to the diffraction, right? Dispersion. Why a glass prism is able to produce spectrum of sunlight whereas a glass slab does not produce the spectrum. So this is also we have discussed. A prism is a non-parallel surface, so light enters in one inclined surface and exits from another inclined surface. As light passes through the prism, it undergoes diffraction twice, once on entering and once on exiting. Because of the surfaces are not parallel, the angular separation between the colors increases after exiting. The result is a spectrum of color spread out. Light refracts when entering a glass slab, but the second refraction on exiting cancels out the angular dispersion causing by the first refraction. So glass slab has parallel surfaces, so from one surface it is getting dispersed, but from the other surface it is getting remerged. Okay, so that's why you are only getting white color. Why do different colors deviate at different angles when passing through a prism? So as we have discussed in our first part, that different light of color travels at different speeds. That is the main reason that why the light travels bends at different amount when they are traveling through a medium. Okay, so this is the basic reason is that because different light travels at different speeds in a medium. Okay, so speed varies from color to color or wavelength to wavelength. So in right now in your class we mention color, but as you go in the higher class, instead of color we will mention wavelengths. Okay, wavelength is more important, frequency of light is more important, but right now we are only in class 10th, so we will say color. So your life is still colorful, but when you go in a higher class, you will the color will be gone, only wavelengths will remain. Okay, so next question, another long question. Spreading of light by air molecules is called scattering of light. The light having least wavelength scatters the more. The sun appears to red at sunrise and sunset. Appearance of blue sky is due to the scattering of light. The color of scattered light depends on the size of the particles. The smaller the molecule in the atmosphere scatters smaller wavelengths of light. The amount of scattering of light depends on the wavelength of light. When light from sun enters the Earth's atmosphere, it gets scattered by the dust particles and air molecules present in the atmosphere. The path of sunlight entering the dark room through a fine hole is seen because of the scattering of the sunlight by the dust particles present in the path inside the room. Okay, so basically they are talking about Tyndall effect. So to an astronaut in spaceship, the Earth appears to be of which color? To an astronaut in the spaceship, the Earth appears to be in blue color. We know that our planet is blue. Why it is blue? Because blue color scatters the most and it reaches to an astronaut who is orbiting the space. Okay, so because the blue color is getting scattered the most, it is reaching the atmosphere astronaut in the space, right? Next, at what time of the day the light from sun has to travel the longest distance through the atmosphere? It is either during the dawn or during the sunset. Okay, so during the sunrise and during the sunset, the light has to travel the most path, right? So suppose this is our Earth, this is the atmosphere. If the sun is here, at this time the light has to travel the most distance, as when the sun is here it is only traveling this distance, but here it has to travel more than this distance. Similarly here also the light has to travel longer distance when it is at the sunset. Okay, so during sunrise or sunset the light has to travel the most distance. Okay, why the color of the sky appears blue? I have answered this multiple times. Because the blue light scatters the most. The answer is also given in the statement. If you read that statement, there also they have mentioned the blue color scatters the most, and after scattering it reaches our eyes. That's why the sky appears blue. All the other colors scatters less and they are not reaching our eye. That's why you don't see other colors. Okay, at the time of sunrise and sunset, which color scattered and which color reaches our eye? So during sunrise and sunset all the colors scatter away, only the red color does not scatter and it reaches our eyes. Okay, red mixed with orange somewhat, but you can mention in your answer that only red color scatters least and all the other colors scatters, so they don't reach our eyes. Only red colors is not getting scattered and it is reaching our eyes. That's why we see red sun during the sunrise and the sunset. Okay, so if you are very careful, if you go to some place where you can see the sunrise and sunset, so you can say you can check it out that during sunrise and during sunset, okay, the sun appears red in color. Okay, so I hope you enjoyed this class, and if you have any doubts in your mind about your future, then don't worry. Diksha is presenting DSAT, which is basically based on 3 parts. First part is a 1-hour lecture, okay, 60-minute lectures and doubt clearing session. Once all the doubts is cleared based on that lecture, there will be a 1-hour aptitude test. What will be in that aptitude test? Whatever is taught in the class. Okay, whatever is taught in the class, based on that class there will be an aptitude test. Okay, how much you can remember, how much you can apply from that concepts, if you have understood the concept or not. So based on that fact, okay, there will be a one-on-one counseling for you, specially for you, based on your result. Okay, how much you have understood, if you are able to answer the questions which are understanding based, if you are able to answer the question which is application based, okay, or if you just answering the question which is remembering based. So based on these facts, the counselor will guide you for your future career. Okay, whether you should choose JEE in future when you are preparing for your 11th and 12th, when you are in PU board, whether you should focus on JEE exam or you should focus on NEET exam, or you are choosing KCET exam for engineering colleges across Karnataka. So that counselor will help you to choose your best future for you. Okay, now whether to choose it or not, that is up to you obviously, but what you have to do, you have to fill is this form. The link is given in the description, and if you are waiting for your future, then don't wait, because this is very good thing for your future. And if you have liked our video, don't forget to share it with your friends, like this video, and I will be back with more videos in upcoming weeks. Till then, bye.